Welcome to this lesson. In this lesson we are going to learn how to draw Lewis structures in the topic chemical bonding. So let's see some of the rules we need to take for us to draw the Lewis structures. Lewis pioneered the use of chemical symbols, and these symbols were surrounded by valence electrons. Take for instance, we have hydrogen there. So hydrogen, we know that its valence electron is 1. So a dot was used to denote the valence electron of hydrogen. Helium has a valence electron of 2. So 2 dots are there. Calcium, it is 1, and magnesium, it is 2. So Lewis pioneered this kind of denoting the chemical symbols. When drawing the Lewis structure, we need to remember that this structure will show electrons that are involved in bonding and non-bonding. And remember, these are only valence electrons. So we have this example of chlorine, which is Cl2. When we look at the valence electrons for that molecule, you realize that it has 14 in total. So this diagram here, or this analysis here, is showing how the lone pair electrons and the electrons which are involved in the reaction can be denoted. So let us follow step by step what one needs to do to draw the Lewis structure. The first step we need to take is to find the sum of the valence electrons in the polyatomic ion or polyatomic molecule. Now, if you are dealing with an ion, we need to remember that if the ion is an anion, you need to add an electron for each negative charge. Whilst if it is a cation, you need to subtract 1 electron for each positive charge. So let's start with this example which we have PCl3. So with PCl3, we need to know that P, which is phosphorus, has the valence electron of 5, while Cl has a valence electron of 7. So with these two, you can say the total valence electron is 5 plus we have 3 atoms of chlorine, so we'll say 3 times 7. Then what is the total which we'll get? If you add all this, it will give you 26. So we have 26 electrons which we'll work with when drawing this Lewis structure of a polyatomic space. So we have 26 electrons which we'll deal with. Now let's go to step 2. So step 2 tells us that we need to look at the least electronegative element, and that should be the one which should be on the center. So for our question, phosphorus is the least electronegative. So phosphorus will be the center of our molecule. So this means it will now be connected by a single bond for all the chlorine atoms which we have. So if we make this, then we have done step 2. So with the structure which we have, when we look at step 3, step 3 tells us to fill the octet of the outer atoms. Now, remember we have 26 electrons. We have 26 electrons. So from what we have used here, this one, and this one, we have used 6 electrons. So we still have 20 electrons to put. So step 3, we will put the octet of the outer atoms. So this chlorine will put, to make it 8, even this one, even this one. So when you add for each chlorine atom, take for instance this one, it will have the 6 electrons plus the electrons from the bonding, which is making it 8. Step 4 tells us now to fill out the octet of the central atom. So we look at these atoms which are outer, the outer atoms. You realize that we had 20 electrons. Now we have used 18 to fill the octet of the outer atom. So we'll say minus 18. We are remaining with 2 electrons. So these 2 electrons are the ones which we will now put on the central atom. So if we do like that, then we have done step 4. So with the 2 electrons which we have added on the phosphorus to reach its octet, we now realize that we remain with 2 electrons. So we have used 2 electrons and we now have no electrons. So this is how it should be denoted. This is how we show the Lewis structure of PCl3. Step 5 helps us to see further what we need to do in a different situation. Now it sometimes happens that you run out of the electrons before the central atom has an octet. So what do you do there? We have this example of HCN. If you look at the total number of electrons for this is 10. And if you draw the Lewis structure for this, putting carbon as the central atom, you'll get something like this as the Lewis structure. You'll note that the central atom here, this one, has not reached octet. So what are you going to do? You will put multiple bonds from the lone pair electrons so that even the central atom can become octet. And this is what we did here. So this should be now the Lewis structure of HCN. So hope this video is helpful. You can now attempt to draw the Lewis structures of those 3 activities which are displaying on your screen. And please, if you have any challenge, you can contact me on the email or through the Facebook page. In the next lesson, we'll focus on how we assign formal charges to each and every element in a molecule as we are drawing the Lewis structure. Don't forget to subscribe to my YouTube channel, that is Cleopas Zulu, and also liking the Facebook page Zuluva Consultants for this and more videos.